Okay, so welcome everybody. Uh, Day one of week two. There's a question right just before we start recording. Someone asked to do problem number 11 from the little quizzy. Okay, it was this picture, and what you needed to see was there was a rectangle, take away the triangle. If you took the rectangle minus the triangle, what would be left is this shaded region. Okay, and that's what they wanted, the area of the shaded region. So the rectangle, they gave you the formula length times width. You put in 19 times 9, length times width, or base times height, whatever, for a rectangle. The triangle was a little tricky. It was that's the formula, 1/2 base times height, but you had to do a little bit of calculation. If the overall base here was 19, and this was 2, and this was 3, then this distance is 14. So the triangle was 14 by 9. Okay, and when you did all that, I think that turned out to be 63. So 171 take away 63, I think, is 108. Okay, so anyway, that's how that got done. I had something I did want to talk about the quiz, but I'm going to wait till more people log in. Well, maybe I won't. Okay. One of the things I said for the quiz on the add work button, okay, I said repeatedly .pdf. Okay, there's a reason for that. Okay, one of the big reasons is if you used HEIC, which is Apple. That's proprietary PDF form for Apple systems. I couldn't read your work. And it says right on your thing, .HEIC. That's Apple only. When, I should say, we upload into Canvas, okay, I spend a lot of time marking up your quizzes and your tests. You send me a quiz or something like that, I'll write comments on it. I'll write on it. I'll show you where your mistakes were. I'll show you, little things. I'll write all over your work and then get it back to you. That's one of the advantages of Canvas. I can write or mark up what you give me, but it has to be a PDF. Canvas will not read HEIC. It doesn't accept it. It just says, I don't know what you are. Okay? So I repeatedly said over the last week and a half, okay, your work had to be in PDF format. So a lot of you got the right answer, but I couldn't see your work, so you lost some credit. Please learn how to use PDF. Okay, Cam Scanner and Genius Scanner are the two easiest ones. I think I sent you that crappy video I said. Okay, it shows you how to do it, but I'll help walk you through it if you need it individually. We'll have to get together at some time and worry about it. But learn how to PDF. Now, before I go any further, I would say of the 27 people that are in the class, about 22, 23 of you just did fine. You got it in. So I'm only talking to a couple people. Okay? So please, no HEIC or anybody else PDF. PDF because number one, that's what I asked for, and number two, that's so in the future I can mark up your work and show you where your mistakes are. So please do that. Okay. Next, we got several people in here. Now, so that was the quiz work. Speaking of quiz, we have another quiz this coming Thursday. It will be on chapter 1 and 2. It will be on Mom. I'll give you more information about it as we get closer to Thursday, but it will be on Mom, and it will be just like homework questions that you've been doing on chapters 1 and 2. Exactly like the homework. All I did was go through the homework and said, ooh, I like that one and that one and that one and that one. So put them on a quiz. Okay, now I changed the numbers. Okay, but that's on the quiz Thursday. Probably what's going to happen Thursday is I'll quit talking around 8:15 or so, maybe earlier, whatever, and say, okay, now, and then I'll open up the quiz on mom. You go to mom, you take the quiz on mom, and you're done. That's it. Okay, so quiz Thursday. Also, last week, somebody asked me to open up the chapter 4 homework. I said I would, and then I forgot. It's open right now. So for those of you who want to get ahead, you finished chapter 1 and 2, and you want to get ahead, and you know how to do it properly, that's always important, you can go ahead and do chapter 4. It's open right now for you to work with. So a little bit of note taking, and we have something that we have to do at the end of class today. Okay, I want to start class tonight with just a little bit of review, and then we'll get into some new stuff, and we'll see how far we get tonight. So the first thing I want to do, just as a review, suppose I define a function g of x is x cubed minus 3x plus 1 divided by x squared plus 6x. Okay? First thing I want you to do is find g of 0. Okay? And then after you found g of 0, the second thing I want you to do is find g of negative 6. Now g of negative 6. That's fine. So we'll pause the video right now and let you guys go to work and do that. So this is a function g of x. Okay, it's defined by this math rule, and when we say g of 0, we're asking you to plug in 0 in place of x. So you plug it in everywhere. You have 0 cubed minus 3 times 0 plus 1 over 0 squared plus 6 times 0. Okay? At this point, okay, I don't care what the numerator is. The numerator can be anything. Turns out it's worth 1. But the denominator is worth 0. So a 0 denominator is technically called undefined. However, when I introduce it, that's the correct math. When I introduced this last week, okay, I also said that mom does it differently. And there was a question on the quiz that said, if the fraction is undefined, write D in E. So a couple people lost credit because they didn't follow the directions. They lost partial credit. Okay, it was like a fraction of a point or something crazy like that. That's why if you go back and look in mom, your scores are like 16.3 and 19.2 because it does give you partial credit. But anyway, the key here is regardless of the numerator, it doesn't matter what that is. If the denominator is 0, the technically correct answer is undefined, but a whole lot of people, including mom, write D in E. Does not exist. Okay, moving over here, we have negative 6 quantity cubed, minus 3 times negative 6, plus 1 over negative 6 squared, plus 6 times negative 6. Again, the top is just going to be ugly here. I don't know what it is. Doesn't matter to me. Because the bottom is positive 36 minus 36. Negative 6, back up here, negative 6 to the second power is positive 36. 6 times negative 6 is negative 36. And if you wanted to say plus a negative 36, that's good enough. That's good enough for you. But whatever it is, we've got ugly divided by 0. So once again, it is undefined. So my purpose in giving these two problems was first and foremost to remind you what a function is, how you say it. You don't say gx, and you don't say g times x. You have to learn to read this in context. This is g of x, okay? And this is its rule, whatever its rule is. The rule can change every time we do a problem. But all this means, g of 0, means plug 0 in place of x in the rule and work out the arithmetic. That's all that means. Okay, so I want to erase that. Any questions on that one? Okay, cool. Then still in review mode, I want you to solve as many of these as you can. Okay, number 1, 2x plus 3 over 5x equals 7 over negative 2. Number 2, negative 6 is less than 5x minus 4, which is less than or equal to 0. Number 3, 2/3 x minus 3/4 equals 1/2 x minus 6. I actually have another one that I want to do, but I ran out of boardroom. So again, 1, 2, 3. If you can't read those, ask me, I'll repeat it, but we'll pause. Okay, let's go back here. This first one was an equation, but it was a special type. It was called a proportion. A proportion is an equation where you have one fraction equaling to one fraction. And there's a super shortcut way for doing a proportion, and that's called the cross multiply. You multiply across the equal sign. And it doesn't matter who goes on the left and who goes on the right. So we would have something like negative 2 times 2x plus 3 equals 5x times 7. And so this gives me negative 4x minus 6, because I distribute the negative 2 in here, equals 35x. Okay? Now remember, the goal in equation solving is to get all your x's together on one side of the equal sign and all your numbers on the other side. So it seems to me more efficient in this problem to add 4x to both sides, and that'll leave all my numbers, in this case negative 6 on the left-hand side, and this will be 39x on the right-hand side. Okay, that's cool. Get x alone, the 39 is multiplying, so we're going to divide 39, 39. Okay. Now's where we run into some trouble. Everybody's in love with their stupid calculators. But if you do 6 divided by 39 on your calculator, okay, I get negative 0.153846154 equals x. And that's wrong. My calculator lied to me. Okay, now, if you see the pattern, You could do this as negative 0.153846 with a bar over it, because by looking carefully at this, okay, you can see that this is starting to repeat this. So it's starting to go 1, 5, 3, but the 8 rounded that 3 up to a 4. So it's starting to repeat. Your calculator is trying to give you hints, but it's not smart enough to give you a hint. Okay? So if you happen to notice that this was a repeating decimal and you wrote it with the bar, great. But my experience says not too many people see that. So an easier answer would be to say solution set negative 2/13. And what did I do? I took this as a fraction. I reduced it. I said 3 goes into 6, 3 goes into 39, divided in both. And I get that. Is that okay with everybody? If you
Yeah,
wanted to use decimals, that's cool, but you have to use them correctly. And I kind of maintain that not too many people would see that that actually is a repeating decimal there. Okay, some of you might, but most of you wouldn't. It's just easier to reduce your fraction and get it to that. Okay, um, okay, I'll leave it as that. Next one over here. This was called a complex inequality. No, excuse me, compound. I beg your pardon, compound inequality, not complex, compound. Okay, because it's got two inequality symbols in one problem. And again, I showed this right at the end of class last week. The game in this is we want to get the x, the middle, to be only x. So we want to get rid of the -4. We want to get rid of the 5. Okay, that's the game. So in order to do that, to get rid of a -4, we're going to add 4 to all three parts. That's going to give me -2, because -6 plus 4 is -2, is less than 5x, which is less than or equal to 4. Okay, now we want to get x alone. So we're going to divide all three parts by 5. Again, if you want to go to decimals, great. But if you just want to leave them as fractions, that's great also. You're done. This is -2/5, okay, is less than x, which is less than or equal to 4/5. 4/5, come on, dummy. Okay, now this is called set builder. Okay, where's my glare? Okay. Did anybody put this into interval notation? I know I didn't ask for it, but did anybody do it, or does anybody want to try and offer an answer in not set builder, in interval notation? Nobody? Okay, no problems. Um, First off, let's look at the graph of this. Literally, this is saying x is in between these two numbers. Just look at what it is. X is in between these two numbers. So your graph would be somewhere between -2/5 and +4/5. And it would equal this, and I'm right in the middle of the glare, and it couldn't equal that, but we would shade in between there. That would be your graph. And I apologize for the glare there. That's in the glare is 2/5 negative. So literally, x is in between those two numbers. That's what my graph shows. X is in between those two numbers. But interval notation just says what the graph shows. So interval notation is parentheses, -2/5, comma, 4/5 bracket. That would be called interval notation.
So if I put decimals, it will be wrong.
No, it wouldn't be wrong. If you had
Um,
-0.4 and zero point 0.8, no, you'd be right.
okay, thank you.
Yeah. I just, I grew up with fractions. Actually, I hated fractions growing up, but I had to learn them, so now I don't hate them as much anymore. Um, so set builder, again, if you left this as -0.4 is less than x, which is less than or equal to zero point 0.8, that's fine. That's okay. I'm happy with that. So that was called a compound inequality. Okay? I'm guaranteeing you on the quiz and when we hit exam number 1 sometime in the future, these problems will be on it. Okay? I might have to erase some of this just to make room for number 3, and I have a 4th one. So how are we doing on here? Can I erase this? Does anybody have any questions? Going once?
I have a question.
Sure.
Wait, I'm still confused on how you got a -2/13.
Oh,
Can you explain that again?
yeah. Okay.
Thank you.
Suppose we take -6/39 as a fraction. Okay. Actually, this is a really good question on your part. You can divide both numbers by 3. 3 goes into both of them, so 6 divided by -6 divided by 3 is -2. 39 divided by 3 is 13. Is that what I wrote? Yeah. Okay. Now, hang on a minute. Let me show you something. Um, Not everybody knows. I mean, you can't just look at a number and say, oh, 3 goes into that number. I know that. Not everybody knows that. Does anybody know the trick for deciding does 3 go into a number? It's kind
Yes,
of a cool trick. What is it?
the ending of 3, 6, and 9.
Nope.
No.
Nope. That won't work. Because I could tell you 59. And 3 does not go into 59. You try it on your calculator. It doesn't go in evenly at all. 29. 3 does not go into 29. So it doesn't have anything to do with the ending of 3, 6, and 9. Or whatever you had. The trick for 3s is if you add up the digits. When you have 39, if you go 3 plus 9 is 12. If 3 goes into 12, which it does, then 3 will go into 39. It's the sum of the digits. Okay? 59. If you add up the digits, 5 plus 9 is 14. 3 does not go into 14, so it can't go into 59. So real quick trick, 5, 7, 1, 6, 2. Okay, without whipping out your calculator, does 3 go into that number, 57,162? Okay, well, if you add these up, if you go 5 plus 7 plus 1 plus 6 plus 2, 12, 13, 19, I get 21. Does 3 go into 21? Yeah, so it will go into that number. So that's a trick for 3s. Okay, however, let me see if I can get my calculator to do this right. I'll probably screw up everything. Bum, 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 bum. Oh no. Stop. This may freeze the whole system, and I don't know. There we go. Aha. Okay, I don't know if you guys can see that or not.
Yeah.
It's a little bit out of focus, but if you look right here, okay, there's a little fraction button. It says square over square. Okay, so if we push that now, I'm gonna push it, and I get square over square. If on the top I put 6, okay, 6, and then I use the arrow down to get to the bottom, to get to underneath 39, okay, and then I arrow off to the side, I now have the fraction 6 over, 39, come on, dummy. Okay, if I press enter, okay, notice it reduced it automatically. Okay, it automatically reduced it to 2 over 13. Now, I didn't worry about the negative. I assume you guys can toss the negative in at the end. But that's kind of a cool feature, okay, that you can get your calculator to do all your work for you. Okay, while I have this here, I want to show you something else. So for the question of reducing 6 over 39, is that okay? Did I answer that question? Are you okay with it?
Yeah, I'm good. I understand now. I just
Okay.
didn't get the whole decimal thing.
Oh, well, that was me making fun of you guys as a student. Everybody has their calculator and they think the
Oh,
calculator is the most wonderful thing in the world, and your calculator gives you all this crud. Well, when my calculator does that, I go, screw it. I'm going back to fractions because I don't want to write down all that stuff.
yeah, decimals. Well, fractions are pretty hard for me too. So it's
Yeah,
just,
but there's a time when decimals are good. There's a time when fractions are good. So when I see my calculator giving me that crud, I go, no way, don't want it. I fall back and go, I'm going to live with fractions because I know my calculator will reduce them for me. Okay?
okay.
So
Thank you.
that it was a good question. It was a very basic question up here, but it led us to some good discussion, a little trick. How do you know that 3 goes into a number? Okay? And it led us to talk about stuff on the calculator. So it turned out to be a really good question. Um, while I'm at it, okay, I want to, okay, I'm going to clear this. Boom. Okay. Uh, there is right here, there's an x squared button, and then above it in blue, there's a square root. This is blue, believe it or not. Okay. So I'm assuming everyone is aware that if you want the square root, you actually press on this calculator, you press second and then the x squared button. And second means, can you guys read? Oh, you can't read my screen. Crap. Okay. I'll do it this way. I'm writing on the screen and forgetting you guys can't see it. Okay. So if you want to do like the square root of 6, okay, what you actually end up doing is you press second x squared button, and on your calculator, you'll see this, okay? So second x squared, where'd it go? Boom. And your little cursor will be blinking inside, waiting for you to put the 6 in. So you do. Okay? But now, So I have this, okay? Now I'm going to push enter. Well, actually, I'm going to go right arrow to get out of the square root. And then I push enter, boom. And it says, hey, the square root of 6 is the square root of 6. Okay, and you're going, yeah, well, duh. Okay, everybody knows that. But if you look right down here, there's an FD key. And what's confusing about this is you don't have to do anything special. If you just push this button right here, okay, boom, it will give you the decimal equivalent. So if you want the square root, great. But if you want what's in the decimal, great also, because the FD key, okay, will go back and forth between the decimal and the square root. Now, several of you, I'm going to clear my screen now. Several of you know or have seen a long time ago, for example, the square root of 12 eventually becomes 2 times the square root of 3. And we're going to talk about how to do that later. But one of the things I like about this particular calculator is it will do that for you. So let me show you how. Okay. So we play the same game again. We go second square root 12, enter, boom, 2 square roots of 3 way off here to the side. So all that simplifying of square roots, this calculator does for you. Again, if you needed the decimal version of that, you push this FD key and it switches it back to decimal form or back to square root form. Okay, now this calculator has other features that I'm going to get into after a while. But I do want to show you one more thing on this calculator. And that is right above the 7. Right above the 7. Okay, so I'm going to go here. Above the 7 key, you'll see this. Okay. What that is that's the way to enter a mixed number, like 2 3/4. So to do that, because that's in blue, you're going to go second 7, and that will show up on your calculator as this. And then you fill in some numbers. So I'm going to do that right now, clear. Okay, second 7, and now it's waiting. Let's say I wanted to do 2 3/4. So I go 2, arrow, 3, arrow down, 4, arrow over. Now let's say I wanted to subtract. That's the one thing. I'm sorry I didn't see who talked last, but you're not the only person who hates fractions or who doesn't like them at the very least. So let's say we wanted to subtract fractions and they go, oh crap, I got to get a common denominator. No, you don't. Let's take away, so minus, okay. Let's go another fraction, so second 7, another fraction. Oh, let's say 12 and 5, arrow down, 6, arrow over. Okay, so for what I've written here, I have 2 3/4 minus 12 and 5, 6. That's what I'm asking the calculator to do. So that's what I've done here. And if I press enter, poosh, okay, it gives it to me as an improper fraction, but it gave it to me right. If you push the FD key, let's see what happens. Notice it's negative. Notice it's negative because it knew that basically, look, 2 take away 12 has to be negative somebody. 2 take away 12 has to be negative, so it's telling me the negative. Let's push the FD key, see what it gives me. Okay, gives me a decimal. Okay, and flips it back and forth. So it flips it back and forth from the decimal to the improper fraction. Whee! Is that going out of focus? No. Okay, so that's a little bit of calculator work, just to show you some of the things on your calculator. Did before I close off this calculator thing and do some other problems, uh, did anybody have any questions on their calculator? Now, I will say I said you can use any scientific calculator. It can't be a graphing calculator and it can't be your cell phone, but you can use a scientific calculator, and most scientific calculators have the features that I just shown you. Most of them do, but you have to read your own owner's manual, and you can go online and just ask for owner's manual for Casio FX, 15 or whatever model you have. And you can get it and download it so you have it there. You can also just ask questions. Casio, change from square root to decimal, and it'll tell you that. You just type that into your Google search. Personally, I use DuckDuckGo or whatever it is. I like that. They don't save my searches and they don't save my little cookies, so I'm a little bit more private. But any questions on using this calculator? None? Okay. We'll come back to it in a bit. So let's go to screen. Oh, no, let's go to video. Come on. Come on. Stop. Okay. Wrong video. It keeps freezing on me. Hello. That's good. Mm-hmm. Yeah, I'm back. I have no idea what I did. Okay. I haven't figured out how to use that camera yet, so I'm afraid I'm going to log us out. All right, let's come back and do this one. 2/3 x minus 3/4.
We can't see you.
Huh. Wait. It froze?
It just says your name.
So what I'm seeing and what you're seeing.
Oh, yeah. Okay, there you go.
Huh. Okay, because it showed me and then it stopped showing me. Maybe it's telling me I'm dressed wrong or something. Equals 1/2 x minus 6. Okay, I guarantee a question like this on the quiz and a question like this on exam number 1. Okay, the concept here was to use the lowest common denominator, okay, the LCD, so between the denominators, 3, 4, 2, what's the common denominator? What do 3, 4, and 2 all go into? Who? I heard somebody say something, but
12.
12, I think, right? You don't need this. The 6, remember, isn't in the denominator. The 6 is a whole number, so its denominator is 1, so it kind of doesn't count. Okay? So what we're technically doing is we're multiplying the 12 times the 2/3 x minus 12 times the 3/4 equals 12 times 1/2 x minus 12 times 6. That's what we're telling you to do. Distribute that 12 to every part of that equation. And then use your knowledge of fractions. Now, whether you can do that in your head, you want to go to your scratch paper or your calculator. This is why I just showed you how to do that on your calculator. You can go 12 times 2/3 on your calculator, okay? Or if you recall last week, we talked about how to cross cancel, not cross multiply, but cross cancel. Whatever, this became 8x. 12 times 2/3 cancels to 8x minus 9. 12 times 3/4 becomes 9 equals 12 times a half, or half of 12 is 6x minus 72. So your calculator work, suddenly it gets, I call this the cat in the hat. Does anybody remember the original cat in the hat story? Where the little kids bring the cat in the hat makes a big giant mess, and then he brings out, what was it, thing 1 and thing 2 or whatever they are, and they make this huge mess. But all of a sudden, the mess gets cleaned up. Okay? Little Dr. Seussian history for you guys. But that's kind of what this is doing. If we distribute the 12 to everybody, our problem looks really, really messy. But if we go to our scratch paper, go to our calculator, it suddenly clears up into a really nice problem. Not a bad problem at all. So real quick, I'm going to take 6x away from both sides. That's going to give me 2x minus 9 equals negative 72. Don't forget, when you bring the 72 down, it's still a negative. Okay, add 9 to both sides. So we get 2x equals negative 63. I think that's right. Yeah, 63. And then divide by 2. X equals negative 63 over 2. The question is do you want to call that a decimal? Do you want to call that 31 and a half? Or do you just want to leave it as negative 63 over 2? Anything you want. Negative 31.5 would be great. Negative 31 and a half, the fraction, would be great. Or this would be great. As long as it's reduced, I'm happy. Is that okay?
Yep.
A lot of talk for that. All right, last problem I want to do, and then we'll go off into some new stuff, brand new stuff. 3 times 2x plus 3 plus 4x equals 5 times 2x plus 2 minus 1. Okay, let's pause. So right about now, you should either be done or you should be at a point where something screwy is happening. According to our rules, the first thing we do is distribute to get rid of all the parentheses. So that should be 6x plus 9 plus 4x equals 10x plus 10 minus 1. If we combine like terms on each side, okay, this becomes 10x plus 9 equals 10x plus 9. Now, some of you can see the answer right now, but I want to continue a little bit more. Okay, we need to get our x's together, so we take away 10x from this side, take away 10x from this side, and all of a sudden, okay, we have a problem, okay? We have no more x's, okay? But we also have a true statement. That's very important. We have no x's, so that means it's kind of a tricky problem. Okay? Something's wrong. But that's not the total game. You don't just quit there and go, oh, WTF, that's it. It's fun to write that down, okay? Because you have to use some analysis. You have to think, that is true. 9 equals 9. So what this problem means is every number in creation makes it true. Come back here to look at this. The only number that you could plug in for x in this problem that would make the left side equal the right side is that number. That's the only number in all of creation that you could plug in up here that would make the problem true. Okay? This is saying every number we plug in makes the problem true. So this is given special name. It's called an identity. Okay, you can write that, or you can write a fancy R, that's like a scripted R, okay, and it means the set of all real numbers, which basically says everything. So this is okay, this is okay. Read the directions in MOM. If it says up in the directions to write identity, then you write identity. If it says write the R number, it shows you how to do that. Okay, that's a fancy R, like a scripted R or something like that, calligraphy R. Okay, fancy R there. Okay, hang on, I want to do more for this, but I want to also pause. Any questions on solving this problem? And how I got to either this answer or this answer. They're actually the same.
Could you, instead of subtract 10x, could you subtract 9? Make it 10x equal 10x. Will that be the same?
Yeah, it would be. I mean, I personally like to get rid of the x's. The key to this is the fact that the left side and the right side were identical to each other. Whether it doesn't matter whether it's 10x equals 10x or 3 equals 3 or -7 equals -7. That doesn't matter. What matters is that the left and the right side of the problem became identical to each other. That's your real clue. Is that okay? Like I said right here, some people could look at that and go, uh-oh, this is a trick question because the left side and the right side are exactly identical to each other. So you could have quit here. Or not quit, I'm sorry, I shouldn't say that. You could have jumped from here to the word identity. That's your actual answer right there, that or that. Okay?
I got a question with the last problem.
Sure.
I still don't get why you times the LCD for the whole problem.
What you're doing is you're making everybody in the problem 12 times bigger. Okay, we already know that as long as we do something to one side of an equation and do the same thing to the other side, that's okay. We're safe. So as long as we multiply this side by 12 and this side by 12, we're okay. Hey, we could have multiplied this side by 5 and this side by 5. That doesn't matter because you're doing the same thing to both sides. But the key here is the LCD is going to cancel each denominator out. Nothing else will cancel those denominators. That's what we're doing. So when you distribute the LCD here, the denominator will eventually be canceled out and it will become a nice pretty number. Okay. Nothing else will. Now, again, understand, I made up a dumb example. I said, could you multiply it by 5? Yes, you could. Technically, legally in math, you could say, I'm going to multiply everybody by 5. And you're not wrong. Except that it doesn't do you any good. Multiplying everybody by 5 isn't wrong. It just gives you screwier fractions. So the LCD is the magic number, okay, that will cancel all of the denominators eventually. Okay,
Is
now
this like a math trick, or this is like actual like, hey, you can do this?
I don't understand.
No, like
It's,
the cross multiplying thing, and then
no, this is a, hey, you can do this.
okay, thank you.
Okay, you can do this. In fact, we're going to come back in the second half of the course when we start the Math 96 part, the real Math 96 part. We're going to come back and use this exact same technique, but for much uglier problems. So the concept of distributing an LCD to everybody eventually wipes out the denominators. That's the concept we want to get in our heads right now. And then we'll come back and do it again on a much more complicated problem.
Thank you.
But not now. I'm setting you up for the future is what I'm doing. Are we okay? Is that okay?
Yes.
All right. On this problem, back here, jumping back to here, guys, what if, sounds like I'm watching a Disney movie here. What if, okay, we had done this whole problem and you got 7 equals 9? What if you'd work this whole problem out and instead of getting 9 equals 9, you got 7 equals 9? What changes? Is it true? Does 7 equal 9? Is that true?
No.
Nope.
No, it's false. That's false. Okay? This is still a WTF problem. Okay? But because it's false, we have a whole different answer. Okay? Let's go back. This number here on this problem was the only single number in creation that made that problem true. When you have this situation, 9 equals 9 or whatever, when you have it true like this, this says any number will make that original problem true. Any number. So there's like 4 gazillion of them that'll make it true. But when you run in, good English, Foster. Okay, when you run into this, okay, that means no number makes this problem true. There's no number in creation that would have made this problem true if that's what we ran into. So for that, we say no solution. Or I prefer, my personal preference is the solution set with nothing in it. Okay, it's the funny braces, but nothing is in it, meaning nothing makes it true. Okay, so my question to everyone is, do you understand the difference between if you run into a problem like this and it's true, or you run into a problem like this, an answer like this, and it's false? That changes your answer, it changes your thinking. And yes, you will run into both of those on exam number 1. Probably not both of them on the quiz, but you'll run into them. Okay. How are we doing? Okay or not okay?
Okay.
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 All right. All right. Then we're still in chapter 2. I want to jump to something brand new. Brand new. Okay. I need to erase this board. Are we okay? Anybody yell? You got to yell at me? No. Cool.
I have a question,
Okay.
but
Did
I
I?
don't know. No, but I don't know if it's like dumb. I was like first
Go ahead.
about it. If I got 0 equals 0, it doesn't
That's
change anything, right?
that's true.
Okay, that's
It just matters, are the two numbers the same?
yeah.
That's all that matters. 0 equals 0, 1 equals 1, 9 equals 9. That's still a true statement. So you would write either identity or fancy R.
Okay.
Okay,
Thank
and that was not a dumb question. Okay, did I answer your question? Are you okay?
Yeah, I'm okay. Thank you.
Oh, okay, sure. Anybody else? See, I always love it. I start to erase the board and somebody asks a question. I break my neck stopping. Oh well. Okay, we're going to go into still chapter 2 stuff. We're going to talk about what's called absolute value equations. Okay. We need some background. What's the absolute value of 3?
3.
Anybody? 3. Yeah, is that easy. Not a trick question, guys. What's the absolute value of negative 3?
3.
Also 3, right? So we know that in arithmetic, keyword there, arithmetic, the absolute value, the answer to an absolute value is always positive, but the inside number could be positive or negative. But the absolute value makes the answer positive. Well, what if we tried algebra? What if I said the absolute value of something is equal to 3? What if we worked backwards? What if I told you the answer was 3? Then, based upon our work up here, couldn't you tell me that x might have been 3, because the absolute value of 3 is 3, or x might have been negative 3? X might have been negative 3. If the answer was 3, then x might have been 3, or it might have been negative 3. Okay? Well, that has some major implications, that this stuff up here. What if I gave the absolute value of 2x minus 3 equals 7? The absolute value of 2x minus 3 equals 7. The thinking you must do is you must say, oh wow, the answer is 7. So this inside might have been worth positive 7, or it might have been worth negative 7. I don't know. The inside quantity might have been worth negative 7, or it might have been worth positive 7. That's the only way we could get an answer of 7. So that translates into this. 2x minus 3 might have been worth 7. Or 2x minus 3 might have been worth negative 7. Super important concept right here. Absolute value equations always split into two different equations. You split and you drop the absolute value symbol, because the absolute value could have been worth 7, or it could have been worth negative 7. Now you solve each of these, okay? By now, we're getting pretty good at it. We're going to add 3 to both sides. So we get 2x equals 10. Divide by 2. And we get x is 5. Or come over here, add 3 to both sides. and we get 2x is negative 4. Okay, divide by 2, and we get x is negative 2. Whoops. So bring it back together. Your solution set, remember I introduced the concept of solution set. This is where you put all of your answers. And so we've just introduced all kinds of crazy new concepts. The first concept is an absolute value equation always splits into two possibilities. Always splits into two possibilities. You'll get two answers, two different answers, but you put them into a single solution set. The solution set is, these are my answers. Look here. That's what you're telling everybody. You're saying, hey, dummy, or dummy instructor, sir, whatever your name is, look here, because these are my answers to this problem. Okay, even though I separated it, did some work here, you bring it back together into there's my answer. Okay, that's the whole concept in a nutshell. I'm going to make it more difficult in a second, because it does get difficult. But what you say to yourself is, oh, the inside quantity, whatever that is, no matter how pretty it is or ugly it is, it might have been worth 7, or it might have been worth negative 7. So you have to write two equations for each of those possibilities, solve each equation, and then put the answer back in solution set. Okay, before I throw another example at you, questions?
Yeah, I have a quick question.
All right, go ahead.
Does it matter where like the 5 goes and the negative 2? Like,
No.
no?
The solution set just is, these are my numbers. These are my answers. So what you're saying is, does it matter if I said negative 2 and 5?
Yeah, because
Yeah.
like when you're graphing the X and Y.
Good comment. And this isn't X and Y. This is just X and X.
Oh, okay.
These are just two numbers on the number line. But it's not X and Y. That's a really good distinction. I'm glad you brought that up. Thank you. Did you guys all hear her question and do you understand it? For the solution set, I don't care whether you say 5, negative 2, or negative 2, 5. They mean the same thing. Okay? And she correctly said, but for graphing, it means something different. And yeah, it does. Okay. Any other questions? Okay. Then we'll try this one before I give you a really ugly problem. I want you to solve this one. X over 3 minus 4 absolute value equals 5. So let's pause while you guys think about that. All right, so again, you're looking at this problem, you're saying it equals 5. That means the inside quantity could have been worth 5 or it could have been worth negative 5. We don't know. So we have to try both possibilities. So because of that, we say x over 3 minus 4 equals 5, or, oops, x over 3 minus 4 could have been worth negative 5. Okay, that's the first key step. Any screw up there, the rest of your work is a waste. So that's the key step. Now, solve each one. We're going to add 4 to this side and this side. That's going to give me x over 3 equals 9. Now, a little bit tricky here. This is x divided by 3. So to get the 3, or to get the x alone, we're going to multiply by 3. Because multiplication and division cancel each other. But we have to multiply this side by 3. Keep it balanced. So we have x is 27. Okay, I got that one right. Over here, we do the same thing to the second equation, add 4, but this time we get x over 3 equals -1. Again, we're going to multiply this side by 3 and this side by 3, so we get x is -3. Bring them back into a single solution set, 27, -3. And that's it. Okay. It does get a little bit trickier than this. Okay, a little bit trickier, but these are the basics right now. So before I get tricky on you, are we okay with either of these problems?
I have a question.
Sure.
The way that I remove the fraction is I multiply 3 to 4 and 5.
Yep,
So
that'll
I
work.
got, yeah, so the first one I got x minus 12 equal 15. So x equal 27.
Same answer.
Yeah, the second one I got x minus 12 equal -5.
Ah, you forgot to multiply by 3.
Oh, I see. I see where I'm missing at. Thank you.
You okay? All right,
Yes.
no problem.
Thank you.
Yeah. All right, anybody else? Okay, well, I got to give you some rules now. Okay. Okay, I've just shown you some examples. Now we got to talk about some rules. When you're solving absolute value equations, first you must isolate the absolute value. I'll show you what that means. Second, you split it up. Okay. Third, you solve, I call them the babies. And fourth, you have your single solution set, all your answers inside there. Okay. The only difference between what I've written here and what we were doing before is this first step, isolate the absolute value. Okay. So what if I had, and I'm going to walk you through this one, 5 plus 2 absolute value 3x minus 1 equals 17. I'm going to walk you through this. Okay. The absolute isolate means get the absolute value all by itself on one side of the equal sign. Get the absolute value all by itself on one side of the equal sign. So somehow or other, we have to get rid of the 2 and the 5. Legitimately, we just can't erase them. We got to get rid of the 2 and the 5. Okay. So this is what I see in this problem, where capital A stands for the absolute value. Okay, instead of writing this big ugly problem, I see a simpler looking problem. So I say in this problem, I would take 5 away from both sides. Okay, and I would get 2a equals whatever that is, 12. So up here, we're going to take 5 away from both sides. 5, 5. And we get 2 absolute value equals 12. So in my mind, this problem and this problem are identical to each other so far. But what happens is students get all panicked. They see these absolute values and they go, oh, it's something special, okay? Well, it is, but it's just not that bad. So when things start getting ugly for me, I always make a simpler problem. I always write a simple problem. All right, what would I do on this problem? I would divide by 2. Divide by 2, divide by 2. And I'd get A equals 6. What would I do on this problem? I would divide by 2. Okay, so I would get absolute value 3x minus 1 equals 6. Now, whether or not you wrote a side problem over here to help you, or you knew to do this in your head, or whatever, you had to take this original problem and move it to here, mathematically, because this is the isolated absolute value. You've isolated the absolute value. Okay, now I'm going to pause and let you finish that. You have about a minute and a half. Okay, so we've isolated the absolute value. Now we have to split. Your thinking goes, if the answer is 6, then this quantity could have been 6 or negative 6. I don't know, so I have to write 2 problems. So I say either 3x minus 1 equals 6, or 3x minus 1 equals negative 6. Not sure. Okay. Add 1 to both sides here. I get 3x equals 7, or x equals 7 divided by 3. Divide both sides by 3. Here, add 1 to both sides. I get 3x equals negative 5. Divide x equals negative 5 over 3. Solution set, bring them all back together again, 7/3, and negative 5 over 3. So the purpose of this example was to show you what isolate absolute value means. You've got to get that absolute value gizmo all by itself before you split. You can't just split it right away. Actually, that's a lie. Sometimes you can. Most of the times you cannot. So it is safer to have you follow these rules. There's a time when you can split it first. Very seldom does it work, but it works sometimes. You're safest if you follow these steps. You'll never go wrong if you follow these steps. Before we do another problem, any questions about that problem?
Yeah, I have a quick question.
Sure.
How come you can't just add 5 plus 2 from like the beginning? Why do you have to subtract from like both sides?
Okay, because you violated Aunt Sally. Oh, never mind. Because if we had this, think about
Wait, I
this
don't
equation.
get that either. I don't get your little
Okay.
A thing.
Well, wait a minute. Think about this equation here.
Mhm.
If I gave you this equation, what would you do first?
Subtract 5
Yeah.
from both sides. Okay.
This A is just my way of saying absolute value.
Oh, okay.
Okay?
Mhm.
So in my mind, and again, 60s drugs, those kind of things, whatever, this, never mind. Okay, bad role model. This equation and this equation, at least at the beginning, are the same thing. So you can't add 2a and 5. They're not like terms.
Mhm.
So you had to get rid of the 5 first. That's what I did here. Is that kind of okay or not?
Yeah. So instead of like writing out the 3x minus 1, you put A so that you
I
can
just-
just solve this.
Yeah.
Okay. Thank you.
Yeah. In fact, if you wanted to do that, check this one out. Let's leave it this way.
Mhm.
And you say took 5 away. So you have 2a equals, well, this was 17, dummy, 17. 2a equals 12. So you took 5 away.
Mhm.
Then you divide by 2 and you get a equals 6. And then you go, oh yeah, but a stood for the absolute value of 3x minus 1 equals 6. So you could do it that way and then go from this point down.
Oh, okay.
Yes or no, or did I talk too fast?
No, I
In other words,
understand.
oh yeah, so you can get rid of the absolute value. If it bothers you and scares you, you can just call it something else for a second.
Okay.
Work the problem out, and then put the absolute value back in its place.
Okay.
Okay? That's totally legit way of doing the problem. Totally.
Thank you.
Yep. Anybody else? Okay. Now, the question was really good because it's a trap. Most people, no, that's not right. A lot of students would try and go 5 plus 2 is 7 and go from there. You can't. Okay, you need to be very careful. You need to be very clear. Unfortunately, I erased this equation. Can I erase my steps here so I can put another problem for you guys to do?
Yes.
Okay. Okay. New example. 3 minus 7 absolute value x plus 4. I'll be nice to you guys. Equals negative 24. Negative 25. Better. Try that one if I didn't screw it up. All right, let's see what happens. I'm going to take 3 away from both sides. Based upon our last discussion, we'll go after the 3. So that's negative 7 times the absolute value of x minus 4 equals negative 28. Divide both sides by negative 7. And I get the absolute value of x minus 4 equals 4. Plus 4. Thank you very much. Copied wrong. That screws it up royally. So that step right there is the isolated step. I've got absolute values. Some of you can do it in your head. Some of you takes 1 step. Some of you takes 2. Whatever, you got to get to here. This is the key. Then we split it up. We say this quantity could have been worth 4 or negative 4. So x plus 4 could have been worth 4, or x plus 4 could have been worth negative 4. We're not sure. This quantity could have been 4 or negative 4. We don't know. Solve it. Take away 4. X equals 0. X equals negative 8. Solution set 0, negative 8. Now I'm skipping a few steps here and I'll be happy to show them, but those are the answers. We doing okay?
How did you get a equals 4?
28 divided by 7 is 4.
Okay, got it.
And negative divided by negative is positive.
I got a question, but when you get a plus 7 and add them on both sides,
Well, where did you get a plus 7 from? Consider that what's this 7 doing to the absolute value? It's implied to be multiplying. So the only way you're ever going to get rid of that 7 is somehow with division of 7.
oh, okay, okay, I got confused. Okay, that makes
Okay.
sense.
Which is why we go after the 3 first. Okay, get rid of the 3, then get rid of the 7, and you get down to here. Anybody else?
Yeah, I just had a quick question.
Yeah.
Say like you had like three numbers instead of like 3 minus 7, you had like another thing too. What number would you do first? All the way to the left?
Give me an example. I'm not
Um,
sure I follow you.
okay, like
Just make up something. It's okay.
okay, so like say you have like 3 minus 7 and then like plus 2 or something, and then the
Oh,
x plus,
okay.
yeah.
2x minus 3 equals, I don't know, 15 or something stupid like that.
Yeah.
Well, these are adding and subtracting, so I would put these together first. So I would put the 3 minus 7 together first. Yeah, left to right.
Oh,
Because there's adding and subtracting. Okay? And now this problem becomes exactly like this problem, or the future one. Add 4 to both sides, divide both sides by 2.
okay. Thank you.
Okay? To be really honest, this problem is probably the worst I would give you on an exam. Can't say what mom's going to do exactly because many of her questions she picks random numbers. So for one of you guys, question number 3 might be easy, and for the next person, question number 3 might be really ugly because mom picks random numbers. Okay? She's supposed to pick nice ones, but that's mom, always laying guilt trips on you. Okay, never mind. Don't want to talk about my issues. All right, let's move on, guys. What time is it? Okay. So that's absolute value equations. That should give you something to do in chapter 2 still. Okay, absolute value equations. Okay. In chapter 2 point, what was it? I don't know where it is. Whatever, I don't know. 2.3, I think. They talk about formulas. Okay. Unfortunately, this is going to take quite a bit of time. So I'm not sure how much we're going to be able to get through this tonight. We'll see. But the first things are you must memorize. Okay? So for a rectangle, you should know these two formulas. The area is length times width, and the perimeter is 2 times the length plus 2 times the width. Now, if you need me to remind you what A, L, and W are, that's fine. I'll do that. But you should know by heart, when it says find the area of a rectangle, this formula should pop into your head. Or the perimeter of a rectangle, this formula should pop into your head. Those should be automatic. Okay? A triangle. Okay? The area of a triangle is 1/2 times the base times the height, or some of you have learned the area is base times height divided by 2. Divide by 2 multiplied by 1/2 are exactly the same thing. If you take 1/2 times 8, or you take 8 divided by 2, it doesn't matter. The answer is 4. Okay? So whether you do 1/2 times base times height or base times height divided by 2, those are both for the area of a triangle. And the perimeter of a triangle, pen is dying, I think. Uh-oh. I'm going through pens like crazy. Oh, yeah. Hang on. Okay. The perimeter of a triangle, it'll get dark in a minute, it has no formula. They just write this. Every time you look it up in a book, okay, what's the perimeter of a triangle? They just say ABC. That just means add the three sides. Okay. There's no magic formula, really. Just add them up. Now, the fun starts with a circle. Okay. The area of a circle is pi times the radius to the second power. Now keep in mind PEMDAS. First you do the power, radius to the second power, then you multiply it by pi. Okay, hang on a minute. The circumference of a circle, circumference is the same as perimeter. It's just anything that's curvy, they call it the circumference. If it's got square or flat edges or flat sides rather, they call it the perimeter. Okay, but because math is weird. But the circumference or the perimeter is 2 pi r, or it's pi d. Now keep in mind in algebra, when we shove a bunch of things next to each other, they all mean multiply. So when we say, oh, the circumference is 2 pi r, well, circumference 2 pi r means 2 times pi times radius, okay? And pi d means pi times d. So that we imply that. Now, a couple things along the line that you need to know is pi is approximately 3.14. It's one of those irrational numbers. Remember I talked about that last week? There's rational numbers and irrational numbers. Well, pi is an irrational number, which means technically its decimal goes forever and there's no pattern to it. Okay? But we get lazy, so we say 3.14. Okay? If you pop it into your calculator, it'll tell you, well, what will it tell you? Oh, where'd pi go? Turned on. 1 pi. Hit the FD key. 3.141592654. Whatever, who cares? If I need it exact, use your calculator, but that's pi. Or, in some instances, they'll tell you to use 22/7. That is a good fractional approximation of pi. Okay, so you just follow the directions. Sometimes it'll say use 3.14, or it'll tell you 3.1415, whatever. It'll tell you that. Just read the directions, okay? Or it'll say use 22/7. Again, both of those are an approximate value for pi. Good enough. Okay? So pi is that. Okay, the last formulas you need to know, and we're going to go over a lot of these, is Pythagoras. Pythagoras, or it's called the Pythagorean formula, or if you had high school geometry, it was called the Pythagorean theorem. Okay, Pythagoras was this ancient Greek guy who, while his slaves worked, nobody bothers to tell you that in high school, okay, while his slaves were working, he was down at the beach drawing pictures in the sand, finding out all kinds of really neat mathematical relationships. So he really was a smart guy because he didn't have to work. He had slaves doing all his work for him. But he figured out that for a right triangle, okay, so what the heck is a right triangle? A right triangle is a triangle with a right angle, a 90-degree angle in it, okay? And we call this a leg, and this a leg, and this is called the hypotenuse. And nobody can spell it, so we just abbreviate it HYP. Okay? And he figured out that if these are the two legs, notice the two legs make the right angle. And notice also the hypotenuse is always across from the right angle. So he figured out that if you take the leg, one of the legs, it doesn't matter which one, and you square it, and then you take the other leg and you square it, it will always equal the hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. Now, in high school, we taught that as a squared plus b squared equals c squared. And that comes back to this, what's the perimeter? A plus b plus c. Leg plus hypotenuse. Just add them all up. Okay, so anyways, I'm going to go over all of these and remind you how to work these out. Now, we may not be able to get to them tonight. I'll give it a try. We'll see how far we can get. But you do need to know these. You need to have these committed to memory. When they talk about the area of a circle, this formula pops into your head. Circumference of a circle, either of these pop into your head. Doesn't matter. They're both the same. Okay? You do need to know those quickly, guys. So that would be the first thing. I would start making flashcards. Okay? Little 3x5 cards. Put formulas. You know, what's the area of a rectangle, perimeter of a rectangle, that kind of stuff. Put these formulas on, make sure you know them. Okay? And not just for me, these formulas come up over and over and over again in all of your future math courses. You think, oh, I'm not going to need this one, this rectangle one, that's too basic. It's going to come up. It's going to bite you in the butt every single time. These are all going to come back. Just when you forgot them, they'll come back. So memorize them. All right, I need to erase the board and do a few problems. How we doing? Can I erase it? You guys got all these copied down?
Yep.
Anybody still writing? All right, I'm going to erase now. Wait for somebody to yell at me. No, okay. Well, one of the things we do in algebra with formulas is we make you rewrite them. So, for example, we want to rewrite a formula. Okay? So you're going to see this in Mom. She'll give you a formula, 2x plus 3y equals, I don't know, let's say 12. I'll make it nice. And she may say, solve for x. Solve for x. That means you must get x alone. Solve for x means get x alone. Okay, so why can't I just say it? I don't know. Solve for x means get x alone. So you want to take this problem and you want to get x by itself. Well, remember that absolute value problem I did. Instead of 2x plus 3y equals 12, I'm going to say 2x plus 5 equals 12. So I'm just going to get rid of the 3y. For a second, in my mind, I'm going to ignore it. What would you do to this problem? How would you start this problem here? Wouldn't you take 5 away from both sides? Sure. So what we're going to do, instead of taking 5 away from both sides of my sample problem, I'm going to take 3y away from both sides of my actual problem. Now, this is where your algebra skills come in. I know that 3y take away 3y goes away, so this becomes 2x equals. Question. It says 12 take away 3y. Can you actually do that in an algebra class? Can you actually do 12 take away 3y? And the answer is no. They're not like terms. So we say, I'm supposed to take them away. I just know that I can't. So that's my best option. Okay? Now, let's go back over to here. If we take that, we have 2x equals 7. 2x equals 7. How do I get x alone? Oh, I'm going to divide by 2. Well, that's what I'm going to do here then. I'm going to do divide by 2. So divide this side by 2, this side by 2. So we get x, because the 2's canceled, equal. Now, don't get fancy on me. That is a good enough answer. You have x by itself. You just solve for x. Okay? I can make it much more complicated than this. I can do more steps, and they're all correct, but so is this. This is 100% correct. Okay? I can show you other ways of doing this. So this is going to be part of your mom homework. Is we're going to give you a formula and then tell you solve it for one of the letters in the formula. In other words, get that letter alone. Okay, before I have you do a problem similar to this, anybody have a question that they want me to clarify? Okay, then, okay. And I probably shouldn't have erased that. I am a big believer in if I have an ugly problem that I'm not quite sure what to do, I write a simpler problem that's kind of related to it and ask myself, what would I do in the simple problem? And then I do sort of the same thing over here. I learn from the simple problem to help me with the harder problem. But if you don't need that simple problem, that's up to you. Okay? If you can visualize it or you just don't even need it, cool. You don't have to write it. Okay, let's take this problem. Same problem. 2x plus 3y equals 12. And I want you to solve for y. Solve for y. Go ahead. Okay, let's see what happens. So I want to get y by itself, which means I want to get rid of the 2x, so I take 2x away from both sides. 2x equals 2x goes away, so I get 3y equals 12 minus 2x. I can't subtract it. I can't write it either. I'm having trouble. 12 minus 2x. Okay. Divide both sides by 3. This side by 3. All of this side by 3. And I get y equals 12 minus 2x divided by 3. And I've just solved for y. Questions? Okay, now I'm going to mess with your brains a little bit. So hang on. 12 minus 2x is the same thing as minus 2x plus 12 over 3. Think about this. 7 minus 2 and negative 2 plus 7, those are the same thing. As long you can switch the order as long as the negative stays with the 2. So 12 minus 2x or negative 2x plus 12, these two are identical. So one person might have gotten this, one person might have gotten this, and you're both right. But it gets worse. Okay? According to our rules for fractions, if you have a plus b over d, right, I picked I would pick the glare. If you had A plus B over D, according to our rules for fractions, the D can divide both pieces, A over D, B over D. Huh? Well, what's that mean? That means I can split this up. Y equals negative 2x over 3 plus 12 over 3. So the 3 can divide both of those. But wait, this is wrong. What? I just told you it was right. I just told you you could split up the fraction if you put the 3 under each part. It's wrong because 12 over 3 simplifies to 4. This is right. Okay, so this is the easiest 100% correct answer. You get this answer up here, you got 100%. Okay. However, the book or a homework problem or something might say this is the answer. Well, they're the same. You're okay. You got full credit. Relax. But sometimes we'll ask you to change it to look like this. That's okay. They just split up the denominator. They said denominator goes into everybody, and then they reduce that. All right. Just want to show you that. We'll work more on it tomorrow night. I need to erase this. Is there anything up here anybody wants to ask a question about? Okay. Suppose for this problem, example, circumference is 2 pi r. Okay, I want you to solve for r. Get r by itself. Okay, so if we have c equals 2 times pi times r, and I want to get r by itself, the easiest way is to divide both sides by 2 pi. Okay, that's the easiest way. So what's going to happen here, because these are all multiplying 2 times pi times r, I can divide 2 times pi. Those cancel, those cancel. So I get r. And this is just c over 2 pi equals r, and you're done. That's it. You're done. It was that easy. That easy. Okay, it's a little bit early, but if I go into a new topic, it'll take me forever, and I don't want to go into a new topic. So I got a couple things. Tomorrow night, we're going to have less review, more getting into the lesson, so more algebra. I think I put in Canvas in the chapter 1-2 module, I think I put a worksheet, something called formulas. Okay. Please download that worksheet. It's something called formulas, something like that. Because we're going to be doing word problems with formulas tomorrow, and it's easier if you have that in front of you. I'm not going to write it up here on the board. It's a pain in the rear. Okay, so if you have it, I'll try and put the problems in the chat just in case, but it's easier if you have that worksheet in front of you. Also, in Canvas, in the chapter 1-2 module, there is an optional, okay, worksheet on absolute value. Okay, optional means you do it for fun. Whatever. You can do it. You can ask me questions. You can do work in Mom. That's up to you. But that's on Canvas. On Canvas, in the Chapter 1-2 module, there's two things there. A formula worksheet. Please try to download it before tomorrow, because that's what we're going to start class with tomorrow night. A lot less review, a lot more algebra tomorrow. Jam things. Tomorrow we're also going to go in, we are going to go into Chapter 4 tomorrow for sure. Remember I said earlier, Chapter 4 is now open for homework. Now, please listen. I want to take roll tonight. But when I sent that survey, there's a lot of interesting things in that survey from last week. One is a lot of you guys are working a lot of hours, and I have no idea how you're going to do all the homework for this class, the homework and study. Okay? That was pretty clear to me. Many of you guys are working 40-hour weeks and taking care of kids. That's just insane. Okay? Remember, between 3 to 4 hours of homework for every 1 hour in class. That 3 to 4 hours of homework means not just do the homework, but study the homework, review the homework, review your old notes, review what you screwed up on previous tests. Homework is not just doing the work in the book. Homework is doing a lot, but that's okay. You guys are going to have to figure out, because it's going to get more and more difficult as the semester goes on. So you might have to adjust how you study, when you study, maybe some of your work for this semester. I don't know. All right. Anyway, on that survey, I got a lot of information from you guys. Thank you. But I also didn't get what I needed in one respect. Okay. I have a program to report your grades on. Special little program that I have. Okay. It's really tight. Nobody can break it. Okay, so your grades, when I post your grades online, I put your grades up online, your grades are really, really private. Nobody can break into this at all. Okay? However, you have to write your name exactly the same way every time. And so, for example, suppose my name was Lawrence Hastings Foster the third. Not good enough. Suppose that was my name. I don't want to write that every stinking time. I mean, yes, it's my name. But if I type that in, at one time wrong, the computer, my grading program, is going to throw you out and say you don't exist. So I would far rather write this, Larry Foster, okay, than all of that garbage. By the way, I'm not a Lawrence and I'm not the third, so whatever. But so that's an easier name for me to type into the computer in order to get my grades back out. So each one of you, now some of you have shortened names already. Great. Some of you have really long names, first name, last name, whatever, okay? Tonight, I want you to send me a shortened, if possible, version of your name. So do you want to type your middle name in? Do you want to type Junior or the third or Esquire or something like that? Okay, so send me your short name, okay, that you won't forget and you won't mistype. So in the subject line of the email. And again, this is at lafoster@sdccd.edu. lafoster at whatever. In the subject line, just put your short name. Okay? You can make it as short as you want. Hey, look, if your name is Joe, but you want to be called Bob, cool. I need a last name, of course, Joe Jones. But you need to be called, you want to be called Bob Jones. Great. Bones? Bob Bones? No, Jones. Okay? You can call yourself anything you want. I don't care. But that's your name, your short name. So that's it. Send me an email at lafoster@sdccd.edu. In the subject line, put your shortened name. Now, some of you, like I said, already have a short name. Cool. You're done. Just put it in there anyway. And with that, get those worksheets. See you guys tomorrow night. Hasta bye-bye.
Bye. Thank you.
Bye-bye.
Thank you.
Thank you.
Oh, wait, I have
Okay.
one quick question.
Yeah,
Have a good
shoot.
one.
Thank you. You too.
The worksheet, do we have to submit that to you?
Nope.
Okay.
You mean the one up here?
Yes, that one.
Yeah. No, that's just, I'm going to do the problems tomorrow. I'm going to walk you through the problems tomorrow.
All right.
Okay? That's all I'm going to do. And it's just easier if you have the problems in front of you. And my screen froze again. Yeah, I love this.
Thank you. Have a good night.
Thank you.